Hello, everyone. I wanted to make a quick video for you with some extra examples for solving rational equations in homework 9. We went through the process in class in one example, but I wanted you to have a video with some extra examples. So our process here, the first thing you're going to do is factor your denominators. You can leave your numerators alone. If you get factor happy and you end up factoring everything, it's no big deal. But it's just less work to just factor the denominators. After you get those denominators factored, make a note of any values that x cannot equal. This is going to come from our domain rule, where if you have stuff in the denominator of a fraction, that stuff cannot be equal to 0. This should feel pretty familiar once we get there. The next thing you're going to do is identify your common denominator. This is going to be exactly the same process as we would to find an LCD when we were adding and subtracting fractions. So you'll identify your common denominator. And then since we have an equation this time, we can multiply both sides of the equation by the least common denominator. We don't have to raise everything to an equivalent fraction. We can just multiply everything by your least common denominator. When you do that, make sure you distribute it to every piece in your equation. And when you do that, the fractions will clear. You won't have any fractions left. You're going to have to distribute and FOIL and multiply out what you have left, and you'll end up with an equation that you can solve. You'll solve for your variable, and then make sure you check your solutions. The solutions that you get can't be equal to any of those values that we made note of up here. Basically, if a solution makes any denominator equal to 0, you have to get rid of it because it can't actually be a solution. So let's do a couple of examples here. So if we start with number 1, we would start by factoring our denominators, but our denominators are numbers here. We don't have any factoring to do. So if we were to get a common denominator here, what would our least common denominator be for all of the fractions in this problem? Between 5, 2, and 6, the smallest common denominator we could find would be 30. And so instead of bringing all of these up to an equivalent fraction with denominator 30, we're just going to multiply both sides of this equation by 30. So we'll take this whole side over here and multiply it by 30. And since we've got fractions, I'm going to think about that as 30 over 1. I can multiply by something that's not 1 here because I have an equation which allows me to multiply both sides by something that's not 1 and still respect the equation. So when I do this, I'm going to have to distribute my least common denominator here to everything. So when I do that, I'm going to get 30 times that x over 5. And then I'm going to get minus 30 over 1 times that 1/2. And this is going to equal x over 6 times 30 over 1 over here. Okay, so to do this multiplication, if it's easier in your brain, you can multiply across and then simplify. I like to simplify as I'm multiplying. So 30 divided by 5, this is going to cancel and reduce, and that's going to be 6. So I'm going to have 6x left here. And then minus, when I do 30 over 2, 30 divided by 2, that's going to be a 15 on top. And so this is going to be 15 over here. And over here, 30 over 6, I can simplify that. A 6 would come out of both, and I'd have a 5 left on top. So when I multiply across, I get 5x. If your brain doesn't like the canceling while you multiply, you can absolutely multiply across here and get 30x over 5 minus 30 over 2 equals 30x over 6, and then simplify each one. So that 30x divided by 5 would be 6x. That 30 divided by 2 is 15, and that 30x divided by 6 is 5x. So if this extra step is helpful for you, go ahead and write it out. I was just programmed to kind of cancel and simplify as I'm multiplying, so that's what works best in my brain. Okay, so now we are here. Our fractions are cleared. This is an equation that I know how to solve. To solve this, it's a linear equation, so I'm going to put anything with an x on one side, anything without an x on the other. So I like to put my x's on the left, so I will, sorry, let me switch colors here. I'm going to subtract that 5x from both sides, and I'm going to add this 15 to both sides. That way, anything with an x is on the left, and anything without an x is on the right. So 6x minus 5x, that gives us 1x over here. These guys go away, these guys go away, and I have 15 left over here. So x equals 15. And I didn't make a note of it at the top, but we don't have any x's in denominators up here. So what that means is we don't have any restrictions um, on the value of the variable. From the very beginning, we usually have to make sure that if you have stuff in a denominator, your denominator can't be equal to 0. But our denominators are 5. 5 is not 0. 2, 2's not 0. And 6. 6 is never going to be 0. It doesn't matter what x is. None of our denominators are going to be 0. So we actually don't have any restrictions from our denominators. Um, that's just kind of a weird thing that happens in these problems with just numbers at the bottom. So that means that x equals 15 is our solution because we have no restricted values. All right, let's try number 2 here. Okay, so the very first thing that we would do is factor our denominators. So I'm going to factor this denominator here first. I can take a 4 out. And when I do, I'm going to get y minus 6 inside those parentheses. And then I'm going to subtract 1. I'll write that as 1 over 1. And this is going to be equal to 2 over y minus 6. There's no factoring to do there. So really this 4 times the quantity y minus 6 is the only factoring that we can do. Okay, so we've factored our denominators. This time we have variables in a denominator. So we have to make sure that the stuff in the denominator is not equal to 0. And so what values of y would make denominators equal to 0? Well, we need to make sure that 4 times y minus 6 is not equal to 0, and we need to make sure that y minus 6 does not equal to 0, right? We'll set each one of our denominators and make sure it's not equal to 0. 4 is never going to be 0, so this isn't going to basically make any difference for us for the value of the variable. And so y minus 6 can't be 0. That means that y cannot equal 6. And for the other one, we will get exactly the same thing. So what that means is that y cannot equal 6. That's the only excluded value in this problem. So I'm just going to make a note of that. If you kind of notice that this is the same, and that's the only thing that needs to be set equal to 0 to figure out what y can't be, you really just need to do one of these. So y cannot be 6. We're going to keep track of that as we solve this. Okay, so now that we've made a note of that, we have to figure out what our common denominator would be. So if we were getting a common denominator between 4 times y minus 6, 1, and y minus 6, what would our LCD be? Hopefully you said 4 times the quantity y minus 6. That will be our least common denominator. It has all the pieces from any of our denominators. All right, so now what we're going to do is we are going to multiply both sides of this equation by our LCD. We're going to multiply this side over here by 4 times y minus 6. And we're going to multiply this side over here by 4 times y minus 6. And make sure to distribute that out to everything. So I'm going to write all of this out. And we are going to get 4 times y minus 6. That's our LCD. Times this 8 over 4 times y minus 6 minus our LCD, 4 times y minus 6 over 1 times this 1 over 1 from here. This is the distribution from here. And that's all going to be equal to 2 over y minus 6 times our LCD of 4 times y minus 6. So everything here gets multiplied by our LCD, and now we can simplify each of these guys. So when we do that, multiplying these guys, the 4's cancel, the y minus 6's cancel, and I'm left with 8 minus, when I do these guys, actually nothing cancels, and what I have here is 4 times y minus 6. And this is equal to, when I multiply these guys, my y minus 6's cancel, and what I have left is 2 times 4, which is 8. Okay. So now this is an equation that I can solve. I'm going to start multiplying that out. So I'm going to get 8 minus 4y plus 24 is equal to 8. 8 plus 24 over here is 32, minus 4y is equal to 8. I'm going to subtract 32 from both sides. So negative 4 is equal to negative 24. And then we'll divide both sides by that negative 4 to get to y. So y is going to be equal to 6. Negative 24 divided by negative 4. So this is our solution. But wait a second. We said that we got y was equal to 6, but we said up here y cannot be equal to 6, because if y was 6, our denominators would be 0. We cannot have denominators of 0. That means this y equals 6 cannot be a solution. We have to throw it out. And that was the only solution that we got. And so since we have to throw that one out, there's nothing left to be a solution. And that means this thing has no solutions at all. And sometimes that'll happen. If all of the solutions that you get have to be thrown out, there's nothing left, and you can say that you have no solution for that problem. All right, let's try one more. I want to do number 3 here. So the first thing we'll do is factor your denominators. 7 over x minus 4, there's really nothing we can do there. X over x minus 2, again, no factoring required there. But over here, so 14 over x squared minus 6x plus 8, this we can factor. My leading coefficient is 1 here, which is nice. That means the two numbers that we find, I'm just going to pop into parentheses with x. And the two numbers that I'm looking for need to multiply to our c value here, which is 8. And those same two numbers need to add to my b value, which is negative 6. Okay, two numbers that multiply to positive 8 and add to negative 6. I think negative 2 and negative 4 work. Negative 2 times negative 4, that gives us positive 8. And negative 2 plus negative 4 gives me negative 6. So those are my two numbers, and I'm going to pop those into parentheses with my x's, and we are factored. So now that we are factored, let's make a note. Is there anything that x cannot equal? Well, because x minus 4 shows up in a couple of these, I got to make sure that x minus 4 can't be 0. And that means that x cannot equal 4. And I have some x minus 2's in my denominator as well. That means that x minus 2 cannot be equal to 0, and that means x cannot be equal to 2. So overall, I'm going to make a note and say x cannot be equal to 2 and 4. This is what I'm going to be keeping track of. Okay, so now that we have the values that x can't be, let's work on solving our equation. If we were getting a least common denominator for this problem, what would that be? Well, we're going to go through and we're going to add factors that appear in any of our denominators. So x minus 4 needs to be in there because it's in a denominator. X minus 2, that appears and it's not already in the list, so I'm going to add that one. And then we're going to check our last denominator here. X minus 2 is already there, so is x minus 4. We don't have to add anything extra. There is our LCD. So now that we have that least common denominator, I'm going to multiply both sides of my equation by x minus 4 times x minus 2. And I'm going to do that on both sides. Sorry that that's a little tight. Okay, and again, make sure that you distribute that denominator to every piece of our equation here. So when we do that, I'm going to get x minus 4 times x minus 2 times 7 over x minus 4 plus that LCD of x minus 4 times x minus 2 times x over x minus 2. And this is all going to be equal to that 14 over x minus 2. If I can get this so that it makes sense. There we go. And I'm going to multiply this side by that LCD as well. Okay, so now we've distributed our LCD to every part of this, and now I can start simplifying. When I multiply these two guys together, my x minus 4s go away, and what I have left is 7 times x minus 2. We can multiply in either order. I'm programmed to put the number out front. We'll end up distributing it through, but I just put the number out front because that's what I was programmed to do. Now let's multiply this second piece here. When we do that, our x minus 2's will cancel, and we will have x times x minus 4. Again, you can multiply in any order, and I like to put the x out front. And when we multiply on the right here, our x minus 4's cancel, and so do our x minus 2's, so we have 14 left here. Now to solve this, we can distribute out our 7. We'll have 7x minus 14 here. Plus, when we distribute out this x here, we'll have x squared minus 4x. And this is going to be equal to 14. This is an equation that I can solve because I have an x squared and some x terms and some numbers. I'm going to put everything on one side. We'll do that eventually, but let's combine our like terms first. I think I'm getting ahead of myself. So let's simplify here on the left. I've got a 7x and a minus 4x that I can combine. The x squared is by itself. 7x minus 4x, those combine to be plus 3x. And I've got a minus 14 here that I don't have anything to combine it with over here. And that's going to equal 14. So to solve this out, because I have an x squared and an x term, I'm going to move this 14 over so that I have everything on one side. So I'm going to have x squared plus 3x minus 28 equals 0. This is an equation that I need to solve. Let's try to factor this. My leading coefficient is 1, which is great. That means that once we find our two numbers, I can just pop them into our parentheses with x's. And so I need to find two numbers that multiply to our c value of negative 28. And those same two numbers have to add to our b value here, which is positive 3. Are there any two numbers that multiply to negative 28 and add to positive 3? Let's see. I know 7 and 4 multiply to 28. So one of them is going to have to be negative and one of them is going to have to be positive. To get a positive 3, we're going to need a positive 7 and a negative 4 will get us there, right? Those two numbers should multiply to negative 28 and add to a positive 3. So I can just pop those numbers in here with x. So now we're factored. To solve this, I'm going to set each factor equal to 0. And I'm going to get x equals -7 or x equals 4. Those are our solutions. And then we just have to go back up and double check our values here. So to check our solutions, really all we're doing is we're going to go back all the way up here and see, is there anything that we have to get rid of? Since x cannot equal 4, we've got to get rid of this one, but -7 is a-okay. And so that means that overall the solution to this one is x equals -7. That's the solution to this thing. You keep any solutions that work, and you got to get rid of any that match your restricted values. All right, hopefully this was helpful. Sorry we didn't get to very many of these examples, and we kind of had to rush through that number 4 in class. So apologies for that. I hope these extra examples helped. Homework 9 is due tomorrow, which is Tuesday, March 28th. If you need an extra day or two, let me know. I'm happy to do that for you. I'm just trying to keep us motivated to stay on track here, because before your next exam, the homework's going to have to be due on a Tuesday. So I was going to try to keep you on a consistent schedule, but I know this is a fast turnaround, and I want you to have time to practice these. So I hope you have a great day, and I'll see you in class on Wednesday.